In this transformation video, we will be discussing stretching and shrinking. Now, you need to pay close attention here because stretching and shrinking can be a bit confusing. Okay, if you want to stretch or shrink a graph vertically, you're going to multiply the entire function by a number. Now, if that number c, which I have on the slide, is greater than 1, that means you're going to vertically stretch it. You're going to make it taller and skinnier. If you have that number c is between 0 and 1, so it's going to be a fraction smaller than 1, then that means you are going to shrink the graph if you're doing it vertically. Now, if you are doing a stretch or shrink horizontally, it's the opposite. So the c is going to get multiplied by the x inside the function. Just like when we were doing horizontal shifts, it was inside the function. Same thing. So we're going to multiply the x by that c. If c is greater than 1, it is going to be a horizontal shrink. So that's going to pull the graph in towards the y-axis. If that number c that we're multiplying the x by is between 0 and 1, it's going to be some kind of fraction that's smaller than 1, then you are going to stretch it horizontally. So you're going to pull it farther away from the y-axis. So in order to achieve that in your chart, so if you have a vertical stretch or shrink, you are going to multiply the y value by a factor of c. And again, your x-intercepts on your graph should not move. If you're going to do a horizontal stretch or shrink, that means you're going to multiply the x values by 1 over c. So you're going to divide by c. It's another way of saying it. And in that case, your y-intercepts will not move. Okay, so these can be a little confusing. So we're going to spend some time. Whoops, wrong slide. Okay, there we go. So we have the graph of f of x shown. Again, the same graph we've been using, that nice piecewise function. Okay, and I would like you to graph 2 times f of x. Okay, so first thing you would do, of course, is always finish your table of values that we have been using the whole time. All right, so because we are doing this right here, we are multiplying 2, which means we are going to do a vertical stretch by a factor of 2. By a factor of 2. What this means is that we are going to make the graph twice as tall, but the x-intercepts are not going to move. So that's the important thing. When you graph g of x, these 3 points should stay exactly the same, because what you're doing is you're pulling the graph away from the x-axis, but those points are like anchor points and they can't move. So we're going to make this graph twice as tall, twice as far away from the x-axis, because right, we're doing a vertical stretch, and just make each. So these 0, when you multiply, you're going to take all these y values and multiply them by 2. So notice 0 times 2 is still 0, right? It's not moving. It's still going to stay. But negative 3 times 2 is negative 6. That's 0, that's 6, that's 0. So this is your g of x. So we took all of our y values and we multiplied them by 2. So this would make this point would go up to 6, and this point would go down to negative 6. So notice we stretched it and made the graph twice as tall and pulled it away from the y-axis. So that is a vertical stretch. Again, stretch because the number we were multiplying the function by is greater than 1. Okay, so if we had this graph, and we wanted to do 1/2 times f of x. Okay, so that 1/2, because it's a number between 1 and 0, that means it's going to be a shrink. So we're going to do shrink vertically by a factor of 1/2. So we're going to make it twice as tall, so it's going to get shorter. Okay, so again, you're going to do the same thing like we did before. You're going to take those values for f of x, the same ones we've been using this whole time, right? 4 was negative 4, negative 2 was 0, negative 1 was 5, 0 was 4, and 4 was 0. Okay, same ones we had before. This time we're going to multiply each of those y values by 1/2. So you're going to multiply by 1/2. So again, notice your x-intercepts are not going to change because 0 times 1/2 is still 0. So all of these that were zeros are still going to be zeros. Whoops. But the negative 4 is now going to be negative 2. It's only going to be half as far away from the x-axis as it was before. 5 would be 2.5, and 4 would be 2. So these parts that are on the x-axis, those were all going to stay the same. But the points are going to be half as far away. So like this point that was negative 4, negative 4 is now going to be negative 4, negative 2. So when it dips down, it's only going to dip down half as far as it used to. And this point that goes up to 5, it's now going to be at 2.5. So it's only going to go up half as far as it was before, and then this. So notice the slope of that line is going to change, right? The slope of this line before was a slope of 1, and now notice it has a slope of, notice we go down 2 and over 4, over 5. So definitely not the same slope that it had before. So right, so it goes down 2.5 and over. So it's got half the slope that it had before, because it goes down 2.5 and then right 5. So this time, rather than having a slope of 1, it has a slope of 1/2. So all of this stuff will affect each piece of the graph. So notice it looks like we kind of took the graph from the top and the bottom and smushed it in towards the x-axis. So that is a vertical shrink. So notice how these can get a little confusing. So definitely take your time when you do these. All right, this example has the 1/2 inside the function. So it's inside the absolute values. So because it's inside that 1/2, it's going to be a horizontal. And it does the opposite. You'd think it would be a shrink like it was with vertically, but because it's the opposite, because it's inside the function, it's going to be a stretch by a factor of 2. That's the opposite. Opposite reciprocal of a half is 2. All right, so what does that mean? It means, so normally this is what our absolute value function looks like. This is what f of x looks like. Looks like an absolute value f of x. So horizontally stretching it, means that we're going to pull it farther away from the y-axis. So now each x value would get multiplied. So rather than going over 1, up 1, we'd go over 2 and then up 1. Right, so it makes it twice as far away. So notice this distance was 1, now the distance from the y-axis is 2. And then the next point would be 2 units away. Well, now we want it to be 1, 2, 3, 4 units away. 1, 2, 3, 4. So notice the slope of my line, which was 1 before, now has a slope of 1/2. So same thing over here. It's going to do the same thing. This point is now going to be 2 points away. This point, which was 2 points away from the y-axis, is now going to be 4 points away. So notice how it changes the slope of that line. So it looks like from the y-axis, I just pulled it away, right? Pulled both of those sides farther away. So again, these can be super, super confusing. So a lot of students usually struggle with these. So I usually tell people, take your time. Definitely, maybe if you need to do those charts, like I showed you in the last examples, maybe that's what you need to do, and actually write down what you're doing to each of the variables. And again, if you go back to the original slide, right, I tell you what to do, like in the chart of values. So make sure you're going back and consulting your notes when you are doing these, because it will help you in the long run. All right, what about this one? This one, we have multiplied it by 4. So that one, it depends on how you want to look at it. You could look at it as it being outside the function, because right, our original function here was f of x equals x. So we could look at it as a vertical stretch, which is probably how, when I look at that, that's the first thing I see. But you could also look at it as a horizontal stretch as well. So we'll look at it both ways. So the first way I'm going to look at it is I'm going to look at it as a vertical stretch by factor of 4. Which means I'm going to pull it away from the x-axis. So instead of having a slope, remember, initially it has a slope of 1, right? So it looks like this. Okay, but this time I'm going to make it have a slope of 4. So I'm going to go up 1, 2, 3, 4 over 1. So now it's going to look like that. And this will be back 1, 1, 2, 3, 4. And again, please don't judge my ability to draw a straight line, because I'm not very good at it. All right, so there's my g of x. Now notice, if you wanted to, you could treat that as a horizontal, like if it was inside, which it kind of is, because the x, the 4 is being multiplied by the x. So you could think of it as being on the inside of that function as well. So that would be a horizontal, and because again that number is 4 and we're doing horizontal, that means we're going to do a horizontal stretch by factor of 1/4. So horizontally, we want this distance 1/4 of the distance. So this point, which was 1 point away from the y-axis, is now 1/4 of the distance from the axis. So I think the easiest thing would be look at 4. Here it is 4 units away, and now notice it's only 1 unit away. It's 1/4 of the distance from the y-axis that it was at the beginning. But notice in the end, you still get exactly the same graph. So sometimes, just like before, you could look at it with either scope. So I usually tell people, don't go with your gut. Whatever you think is your first instinct, run with that. But always know that there might be another way that you could look at that problem. So try to think outside the box sometimes too. All right, so that ends our looking at each of these transformations individually. Now, in the next video, we're going to talk about putting all of these transformations together. So what do you do when you have multiple transformations? Like so far, we've just been doing one transformation at a time. In the next video, we'll talk about what happens when we put it all together. So make sure you come back for that.